Hello, this is Dr. Raz. In this video, I would like to show you how to use Python to be able to calculate outliers using Tukey's approach and go to 1.6, detecting outliers Tukey's method. And then here, you should be able to download the CSV file right here, three dots, download original file, and then also download the Python code right here. And now what I would like to do is go to my browser, open a new tab, and search for Google Colab. And then make sure you sign into your Gmail account and then go to Google Colab and open Colab, close the previous tab and upload, browse. You should be able to open the Python file we just downloaded. Once that file is uploaded, make sure that you click on the files and wait for it to connect. Once it's connected, click on upload button and make sure that you go downloads and upload the CSV file we just downloaded. First part of this code, we will be importing libraries. Again, pandas libraries for handling and analyzing data, and matplotlib library is for creating graphs. And we abbreviated pandas library as PD and pyplot under matplotlib libraries as PLT. So just run this code. Perfect. Now we need to load the CSV file and read that file and write everything in that file to a data frame called df. Perfect. Now we need to calculate the quartiles and interquartile range. So this is how we calculate quartile. So we are telling Python to go to the data frame that we imported data to from Excel file and go look at the transaction amount column and calculate use the quantile function for 25th percentile. That's why we put quantile 1 is 0.25, and same thing for quartile 3 is going to be 75th percentile, that's why it's 0.75, and interquartile range is nothing more than this quartile 3 minus quartile 1. So let's calculate that. Perfect. Now we'll calculate the lower bound and upper bound to identify the outliers. Again, these are our whiskers in our plot. So lower bound is nothing more than quartile number 1 minus 1.5 times interquartile range, and upper bound is nothing more than quartile number 3 plus 1.5 times interquartile range. Run this. Perfect. Now we need to identify, we will create a new column like similar to Excel, and we'll call that column as outlier column. And here we will check to see whether transaction amount in the transaction amount column in the CSV file is less than, this is or symbol right here, or transaction amount is greater than upper bound. If it's greater than upper bound or less than lower bound, it's an outlier. So that's how we detect it. And now we can filter those outliers using this function right here. And then what we can do is we can just print the outliers. And here you can see that these are the transaction dollars and these are the ID numbers, and you can see the amounts, and these are the outliers. So we detected those, and we can create our box plot 10 inches by 5 inches, and we will use the transaction amount uh, column, and we don't want vertical, we want horizontal. So instead of vertical, this graph looks horizontal because of this false. If you want vertical, you can do that as well by just saying true. And the title here is given right here. And transaction label is a transaction amount for the X label right here. And we can just grid line if you want to have grid lines. And we just show this graph. And I will just click on play, and you can see that this is our quartile number 1, this is quartile number 3, this is our median, this is our lower bound, this is our upper bound, and there's one observation here, and there are a bunch of observations here that are outliers. I finished this video. Until next video, enjoy business analytics.